For this self-assessment, you are going to extend the early one on computing the ideal gas law computation and turning it into a table form. This is one of the first things you learn to do as a programmer, is work with a particular computation and show the results of that computation as the values change over some range. In this example, I'd want to know what happens to the change in pressure P given the change in volumes. So the volumes are going to range from 0.1 liters to 2 liters in steps of 0.1. And I want to print a table to go along with that. So there's a lot of things going on here, and we have to figure out how do we break this down. So let's start in Canopy by creating a new file where we're going to do all of our work. And so this would be going to be the day 4 assessment. The trick is we want to think about what the output is going to look like. And this is an approach I've used in some of my past assessments and will continue to use for the rest of this course. If you know what the output looks like, that usually tells you the structure of the program you need to write to produce that output. The output is asking you for volumes in the range of 0.1 liter to up to 2 liters, let's say. And for each of these, I want to print out not just the fact that it's 0.1 liters, but I want to print out the change in pressure that is there. So this is pressure given 0.1 liter, this is pressure given 0.2 liters, and so on. Now in this table, certain values are constant. Temperature is going to be fixed at 20 degrees Celsius, and we know that N, we've already done the computation, we're just going to assume that it's fixed at 0.29 moles. With this in mind, how do you start? Well, the real trick is trying to understand how you can see a loop when you're given just a format of output. When you see this table, you can recognize that if you had 0.1 liters as your volume, you should be able to compute the pressure. This is the sample code you saw that we wrote last time. And if you change some of these values around, you can recognize that you should be able to compute the pressure given all those constants. And you want to compute that again with 0.2 liters, and then again for 0.3 liters, and so on. Now I guess you could spend a lot of time just trying to figure this out for each individual one and repeat the computation over and over and over again. But instead, I want you to see this as a for loop. To make this work, I'll start with a definition called print pressure table. And this pressure table is going to print some information that we're going to use to show the output of this assessment. I gave a hint, and usually that's helpful, to say, well, how would I use this range of 1 to 21 to do some work? As you remember from the lecture, range of 1 to 21 will give you a list of values from 1 to 20. Boy, that looks very convenient because I want to do something 20 times and I want it to be from 0.1 to 2.0. And here, this is very close. It's from 1 to 20. It's just off by an order of magnitude. So let's imagine that we're going to build this up from scratch. It seems like I want to do something 20 times. So I'll say for row in range 1 to 21, let me just print the row. This is going to be day 4. When I run this particular function that I've just written, I get my output from 1 all the way up to 20. All right, this is a start. This is the first column of the table, if you think about it that way. But I need to do a little bit more. Well, first thing is I know that I'm off by a factor of 10. This shouldn't be 1 to 20. This should be 0.1 to 2.0. So I'm going to use a new variable which represents the volume, and the volume is going to be nothing more than rho divided by 10.0. Remembering that I want to convert an integer, which is rho, 1 to 20, into a floating point. And I do that easily by dividing that integer by 10.0. Let me now print out this v that you see here and run it. Now, as you can see, I'm making progress. I now have the left column 0.1 up to 2.0, but I don't have the pressure yet. Well, if you remember from our lecture, PV equals nRT. nRT. In this case, I'm trying to compute for the pressure given I have volume moving in certain ones in nRT, as you see here. So I want to compute for every volume some pressure. And that pressure is going to be N times R times T divided by V. Now if I have all these constants defined, that is, I assumed that N was 0.29 moles, and I assumed that the Celsius, the temperature, was equal to 20 degrees. And again, this is in Celsius, so I have to add the absolute zero constant we've talked about before to convert this into Kelvin. So now I have the N. I don't yet have R. R is going to be that special constant that I need to have. I'll just copy it from here. Now with all this information, I know that volume is in liters. I know that N is in moles, my temperature is in Kelvin, so I have all the right parameters in the right units themselves. And I've computed P, and I need to do something with it. Well, if I print V and then I print P, sometimes you just want to experiment and see what happens when you type code that looks like something else. Well, this is looking plausible. It looks close. It says, well, look, if you 0.1 is the volume and its pressure is 6.9. When the volume gets to 0.2, the pressure goes down. When the volume is increasing, the pressure goes down some more. But these are printing on alternating lines, and that's not what I want. I want a table that has two columns showing me the volume in the left column and then the pressure in the right column. What I want to do is I want to put these together. And the key observation here is not that you want to print the volume and then print this pressure at the end. The key observation is you want to print the volume and then next to it you want to print the pressure. Now, in the lectures you've seen me use this string concatenation to accomplish the task of taking one value and another value and putting them together side by side, left to right. That works when you've got strings. But here I don't have strings. I've got floating point numbers, volume and P, pressure. So what I want to do is convert these into string representations. This is a string representation of V. And to see how this works, again, this is still going to give me just the leftmost column when I run it. But at least I've got the right values. And to do concatenation, the plus operator that you've seen works on literals as well as numbers. I want to somehow put these two together. Well, that's close, I guess, but I have to remember I got to put a space in between, otherwise those values will be scrunched up right against each other. So if I take this next logical leap, and this is of course the inspiration that makes this whole problem work, I want to do something for every of these liter volumes from 0.1 to 2.0. What do I want to do? I want to compute the pressure, and then once I have that, I want to print them out side by side. So if I convert V into a string representation and then concatenate it with P, the string representation, this is very close to having the solution, but as you will see, the numbers run into each other, so I don't want that. But if I just insert another quote space quote, which is a string literal that represents the space character, I can now concatenate these from left to right. So I've got the volume first, then I've got a space, and then I concatenate that with the string representation of the pressure. So now when I do this, I kind of have a nice little table that shows me here's my volume and here's the pressure that's associated with that volume, assuming the other temperature and number of molecules remain constant. So this is essentially to solve the problem. When you have a table, it can be helpful to have a header at the top, just to remind you what the types are. So I'm going to put this at the top saying volume with a space, and then pressure. So that now I've got not only the right information, but I've actually made it a little bit user-friendly to read through that with the volume of 0.1 liters, the pressure is 6.97 atmospheres. In this small exercise, there's a lot going on. And if you are confused about any one of these small parts, be sure to read the lecture notes to make sure you've understood the skills that you need. And please go back and review this video because it can be instructive to see how I solved it from scratch, which is a skill that you need to do in this course. This completes the assessment.